Hey everyone, and welcome. Ever wonder how you can take the simplest shape you can think of and turn it into something, well, extraordinary? Today, we're going to trace that exact journey. We'll start with a wild idea about architecture, get into the cool geometry that makes it all work, and then see how it all ends up as a modern digital creation. So yeah, let's dive right in.
So our story really kicks off with this total visionary, a guy named Buckminster Fuller. And he wasn't just any architect or inventor. See, he didn't just want to design buildings, he wanted to completely blow up our ideas about shelter, about efficiency, about, living itself.
And this is where he actually put those big ideas to the test. This is Fuller's real-deal geodesic dome house in Carbondale, Illinois. I know, it looks kind of like a spaceship landed in the suburbs, right? But this strange-looking structure, it's the jumping-off point for this whole story. It's where the idea became real.
Okay, now take a look inside. When you look up at that ceiling, you can really see the genius at work. The entire structure is this incredible web of interlocking triangles. And what that does is create this huge open living space with zero need for internal support walls. It feels unbelievably strong, but at the same time, it's just so open and spacious.
So, the big question is, how in the world do you get from a simple, flat little triangle to that huge, curved dome? Well, it's this really fascinating geometric process that builds up, just one simple step at a time.
And believe it or not, this is our only starting material. Yeah, that's it. Everything we're about to see, from that dome house all the way to a super complex sphere, is built from this one humble little shape. It is the absolute fundamental building block.
Okay, first step. You take 20 of these triangles and join them all edge to edge. What happens? They just naturally fold up into this shape, an icosahedron. It's actually one of the 5 platonic solids, which is just a fancy way of saying it's a perfectly symmetrical 3D shape where all the faces are identical.
All right, this next step is absolutely crucial. Imagine you take that icosahedron and you just slice off each of the 12 corners, the vertices. When you do that, you reveal brand new faces. This whole process is called truncation. And what do you know? It creates that classic pattern of pentagons and hexagons that we all know from a soccer ball.
But we're not quite at a sphere yet, right? To get it smoother and more rounded, we take those new, larger faces, the pentagons and hexagons, and we break them back down into our original building block, the triangle. And the more you subdivide, the rounder and more intricate the whole thing gets. And here's the final result, a beautiful, complex sphere, made up entirely of triangles. This is the essence of what we call a buckyball, or a geodesic sphere. It's this complex, amazing whole that was born from just repeating a super simple part over and over again.
Now, you might be thinking, this is all magic, right? Getting all those flat triangles to fit together on a perfect curve? Well, it's not magic, it's math. And while it looks totally artistic, there's this really rigorous, super elegant mathematical engine just chugging away under the hood.
Don't worry, we're not about to break out the calculators or anything, but it's super important to get that making this work requires some really precise calculations. It's just the perfect marriage of, creative vision on one hand and cold, hard mathematical logic on the other. So here's the basic process laid out. You start with that simple triangle, you build the icosahedron, you chop off its corners, and then you use some pretty high-level principles like spherical trigonometry and subdivision to project the whole thing perfectly onto a sphere. Every single one of those steps is a key piece of the puzzle.
Okay, so why does any of this matter today? Well, what's really cool is that these exact same principles can be used in the digital world. I actually wanted to see if I could take this whole geometric journey myself and use it to create something totally new, a digital trophy for an honors conference in education.
And this is where that transformation really starts. On the left, you've got our perfect geometric Buckyball. And then on the right, you can see that exact same digital model being dropped into a base. It's starting its brand new life, not just as a cool concept, but as an actual, tangible object.
Next up, I had to transform those simple geometric lines. So instead of just flat faces, I gave the whole framework this intricate, beveled structure and a cool metallic finish. It basically turned the mathematical skeleton into something that looks and feels, substantial.
Of course, an award needs to stand proud, right? So a solid base was designed and added in. This step really grounds the sort of ethereal geometry of the sphere and gives it the weight and presence of a real-world trophy.
And here it is, the finished piece. The text was added for the first-place winner of a student research symposium. The journey is totally complete. We went from a single triangle to a house to a geometric sphere, and finally to an award that celebrates academic achievement. How cool is that?
You know, this whole process, it isn't just about architecture or digital design. It's a really powerful example of how one simple idea can be built on, step by step, to create something truly incredible.
And that's really the big takeaway here, isn't it? You have a visionary architect, a powerful geometric rule, and modern design tools all coming together. And the whole thing started with just one little triangle. It really makes you wonder, doesn't it? What's the simple idea you're holding on to that could be the start of something amazing? What will you build?